6, we're going to be talking about polar on your calculator. Later on, you'll notice that there is a mode that says POL, which stands for polar. And there's some vocabulary that's kind of important when you're working with polar. So first of all, in this diagram up here, we have our what we call the polar axis. This will be important because on your test they'll talk about the polar axis. In the past, we've called the polar axis the... That's a pause for you to respond. The x-axis. Yep, good job. We've also used the word pole in a different way. So you'll notice that they talk about the pole right here. Instead of the word pole, we used to use the word
vertex.
Origin is correct. And so these words are things that we've already dealt with. They just have different names. And now when they talk about coordinates, instead of our coordinates being x and y, we're now going to use r and theta. The r stands for a distance that you're moving, and the theta stands for the degree measurement that you're moving in. So, for example, so let's look at a few examples of that. Again, we are now talking about some distance called r at a certain angle measurement called theta. Theta can be in degrees or radians. Just depends if your test tells you which one it is. That's what you have to use. If it doesn't tell you, I don't care. You can use radians or degrees. In these first two examples, it'll say plot the following points in the polar coordinate system. You notice this very nice graph that we have here. And it says, look at the coordinates 2 pi over 4. That's talking about r and theta. Now, I'm not really sure why they put r first and theta second, because that doesn't really make sense to me. I don't know about you guys, but to me, I need to know which direction I'm facing first before I start moving. So I would have, if I were to make up this coordinate system, I would have said theta comma r. But if we look at this, I look at the pi over 4 direction, so I'm standing on the pole, I spin the pi over 4, and I walk out 2 units. That means that my coordinates for 2 comma pi over 4 are right here. 1, 2. Simple as that. And the next one, 3 negative pi over 6. The negative pi over 6 says instead of spinning counterclockwise, I spin clockwise. And then walk out pi over 6. Or, pardon me, walk out 3. So here's negative pi over 6 right here. Negative pi over 6. And then I'm going to walk out from the pole 3 units. So 1, 2, 3. Here's where I am. The only thing that the negative does is it tells you spin in a different direction. We already learned about that back when we were talking about the unit circle. Questions on either of these? So in part C, first of all, you're going to spin the pi over 6. If you spin the pi over 6, that means you face pi over 6, which is right here, and you walk out negative 2 units. So that means instead of going towards the pi over 6, you're on the pole and you go backwards pi over 6, 2 units. That means you're right here. So your eyeball was looking in this direction, but you had to walk backwards 2 units. That's what the negative 2 means. And in the last one, you're going to spin to negative 2 pi over 3, which means you're going to be going in the clockwise direction. So I go clockwise to 2 pi over 3, which is this direction. This is the negative, that is, of 2 pi over 3, or in other words, clockwise 2 pi over 3. But then as you stand at the pole, looking at this direction of 2 pi over 3 in the negative spinning, or in the clockwise, you walk backwards 3 units. So that means you start at the pole and you go 1, 2, 3. Or in other words, I'm standing right there. Now the strange thing is, this means that you have to understand that there are multiple representations for doing anything. It's very frustrating as a teacher to grade tests because you can actually write down a coordinate that's completely correct and not the thing I would have wrote down because there are so many ways to represent something. So for example, I talked about my very first one, spin 45 degrees and walk out 3 units. That's one way I could have done it. But another way I could have done it is instead of spinning to 45 degrees, I could have spun in the opposite direction, way over here, at 225 degrees and walked back 3 units. Or I could have spun, if I wanted to, negative, so that would have been, I said 225, but I spun the wrong way, so here's 225. I could have gone negative and then walked backwards. I mean, there are so many different ways to do it. So what we're going to do next is we're going to actually do that. We're going to show like there are multiple representations. So here in this next example, what you'll see is they talk about this 2 comma pi over 3 coordinate. So pi over 3 is right here. That's frustrating. And if I walk out 2 units from the pole, 1, 2, this is the location of where I want to end up. And what I want you to figure out, and then I'll come back and I'll show you the ones that I found, is I want you to find 3 other ways to write down that highlighted blue coordinate. When you're done, compare with a neighbor. I think, okay, look, I need to get to this blue point. Doesn't matter how I get there. So one way is to spin the pi over 3 and then walk out 2 units. That's one way. I could, if I wanted to, spin the other direction. And also walk out 2 units. If I were to spin in the opposite direction, that means I'd have to be going in a negative direction. And I know that no matter what happens, I know that it's always some kind of pi over 3 angle, no matter what. So what I have to think about is, where am I in the negative pi over 3 realm? Well, I'm almost all the way back to the origin, so I'm at the farthest negative pi over 3 I can be, which happens to be negative 5 pi over 3. And I still faced out and walked in a positive direction, which means I went 2, comma 5, negative 5 pi over 3. So that's one way I could do it. Another way I could do it is that I could walk in the positive, or sorry, spin in the positive direction, or in other words, spin counterclockwise again to the pi over 3 thing. But this time I would have to walk backwards to get to that dark blue point. So if I spin to that pi over 3, that pi over 3 was positive 4 pi over 3. But if I'm facing away from my point at 4 pi over 3, I now have to walk backwards 2 units. So that's a second way I could get there, or a third if you consider the original. And the last way would be to do the same kind of thing, but to go in the negative direction. So if I spin in the negative direction, some kind of pi over 3, now I have to think, okay, wait, that's past negative 1 pi over 3, and I'm now in the third quadrant, so that's negative 2 pi over 3. But I'm still facing the wrong way, so I have to walk backwards 2 units. And what I want you to notice is if you consider the original dark blue, I want you to notice that there are coordinates that have positive and positive. There are coordinates that are negative and negative. There's coordinates that are positive and negative, and ones that are negative and positive. Did you notice that? 4 different variations. Positive, positive, negative, negative, positive, negative, and negative, positive. Also, all the numbers are 2's. All the angles are pi over 3's. There's 2 positive 2's, there's 2 negative 2's. There's 2 positive pi over 3's, there's 2 negative pi over 3's. Lots of patterns. So as you're going to find these 4 coordinates total, you should see one of each of these things. And that'll help you determine whether or not you found all the correct ones. Questions? Okay, so we've already seen this special triangle. And what I want to remind you is they can choose whichever way they want to do it. If you remember SOHCAHTOA, we talked about this so many times. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. That's what they're doing in this red triangle right here. They're looking at this red triangle. They're saying, hey, we got a right triangle. I know that my angle is called theta. And I want you to talk about the sine, cosine, and tangent. So I notice that I have the sine is the opposite over the hypotenuse. I have the cosine is the adjacent over the hypotenuse. And I have the tangent is the opposite over the adjacent. Why? Because they are calling the x thing the adjacent. They're calling the y thing the opposite. And the r is the hypotenuse. Does that make sense for you guys? Sine, cosine, tangent? Okay? All right. If you look at those, let's just look at the sine and the cosine one. If you rearrange the sine, there's the rearranged equation. What happened? I took the original blue highlight and I multiplied both sides by r. And I got the y alone. So y is equal to the radius times the sine of theta. In the purple, you look at the original purple equation, you see that your cosine is equal to the adjacent over the hypotenuse. If I multiply both sides by r, this is what you would see. Your x is equal to r times the cosine of theta. These purple and blue equations are going to be used in the next things that we do. So now we look down below and notice how the phrase is saying convert. That means that instead of being in r theta, I want to be in x, y. So when they say that you're changing from polar to rectangular, what that's saying to you is that you're going from r and theta to x and y. So this is your goal. You're trying to get into x and y. If you look up above, we have techniques to help us do that. So in the purple, I see that if I'm looking for my x value, I take my radius, and in A, my radius is 4, and I multiply it by the sine of theta, which is pi over 6. That's from the purple equation up above.
Wait, what is my cosine?
Oh, pardon me. Did I write down the sine? I'm sorry. Thank you. You are indeed correct. It is cosine. So the cosine of pi over 6 is the square root of 3 over 2. So as I simplify this, I actually have 4 times the square root of 3 over 2 from my unit circle. Or in other words, 2 radical 3. If I'm looking for my y value is 4 times the sine of pi over 6. From our unit circle, we know the sine of pi over 6 is a half, so this is really like 4 times a half. Or in other words, 2. And what this is saying is when I get done, since I'm looking for my goal to be in rectangular coordinates, or in other words, x and y, my coordinates are really 2 square root of 3, comma, 2. What this is saying is that instead of going to pi over 6 on my pole, spinning in that direction and walking out 4 units, what I could have done instead, if I wanted to talk to you, is I could have said, hey, face along the x-axis, walk out 2 times the square root of 3, turn and face in the y direction, and walk out 2 units, and you end up in the same place. That's what it's saying. So 2 different ways to talk about how to get to the same location. One is in what they call polar, r comma theta. One's in what they call rectangular, x comma y. Tristan.